So there are two different types of compound inequalities. Compound inequalities means basically that I'm putting two different types of inequalities together and I'm going to have to solve them both. So the first compound inequality I want to talk about is an AND inequality. Let's look at the example. Negative 3 is less than or equal to 4x plus 2 is less than 9. So notice that I got two different inequality symbols and I have it sitting linearly. Okay, so we're looking at negative 3 is less than 4x plus 2 is less than 9. All right, this isn't that bad. What you have to do though is you have to simplify this by breaking it down into two different inequalities to solve. So this is my first inequality that I need to solve. And this will be my second inequality that I need to solve. So it's basically where I have the information up until the inequality symbol. So I got number, inequality symbol, some numbers, maybe a variable, and then the inequality symbol. And that means that tells me that's where I need to stop with my box. So I'm going to write down the blue information first, which is negative 3 is less than or equal to 4x plus 2. The other one is 4x plus 2 is less than 9. Now, what we have to do is we have to solve these both. We're going to solve them separately. So let's solve the first one over here on the left. To do that, we have to get x by itself. So we're going to subtract 2 from both sides. We're going to get negative 5 is less than or equal to 4x. I'm going to divide by 4. Since the x is not negative, we don't have to flip anything. This is going to tell us that x is going to be on my right-hand side. Negative 5 divided by 4 is negative 1.25. Now, we don't like this because x is written on the right side. We want it on the left. And so we're going to flip the whole thing around. And that's going to tell me that x is greater than or equal to negative 1.25. Now, I got to do the same thing, but I want to move over to this other one and solve it. So we're going to subtract 2. We're going to get 4x is less than 7. We're going to divide by 4. And x will be less than 1.75. So that tells me that x is going to be somewhere in between negative 1.25 and 1.75. And so you may say, well, how do I graph this? Because I got to graph it. Well, you're going to graph it all on one number line. This time, though, I have two answers. So what we want to do is the left side is the smallest side of this number line. So that means negative 1.25 has to come before 1.75. So let's go ahead and put negative 1.25 on the left-hand side. And let's put 1.75 on the right-hand side. So what I have now is I have these two numbers that I'm trying to figure out how they go. So negative 1.25, if you notice, my arrow is going to be pointing to the right. It's going to be a closed dot with my arrow pointing to the right. If you look at x is less than 1.75, that tells me I'm going to have an open dot above there. And that guy is going to be going to the left. Now, you may say, well, what's this all about? Well, that's not my answer yet. See, my answer is everything that is connected in between. So here, my solid dot, all the way up to my open dot is my answer. So I really don't need this arrow here and this arrow here, because my answer is really going to be written with a solid dot, a line, open dot. And that's my answer. That means that x can lie anywhere between those two values, including negative 1.25 and excluding 1.75. And that's because of the open and closed circle concept. But we got to look at the other portion of this, which is an OR compound inequality. So we have a and we have an OR. If you notice, the ands are connected to one another. ORs, most of the time, are not going to be connected at all. So let me show you an example of that. We have 4x plus 2 is greater than 9, or we have 7 is greater than 9x minus 2. Now, the nice thing about this is they're already separated. So when we have an OR statement, we already have two separate inequalities. When we compare that to the AND one, those we had to actually create our inequalities. Now we have these things that are separated. So I can solve them both separate. So on this left side, I'm going to have to subtract 2. I'm going to bring down my 4x is greater than 7. Divide by 4. And I'm going to get x is greater than 1.75. Again, I don't have to flip anything because x is now on my left and it doesn't have a negative number. So we're going to go over here to the other side. We're going to do plus 2. We're going to get 9. That means 9 is greater than 9x. We can divide by 9. That means 1 is greater than x. Now I can't have x on the right side again, so I have to flip this whole thing around. And now I have these two answers. And again, we're going to graph these two things on the same number line. So we're going to draw a line. The left side being the smallest would have to be 1. The right side would have to be 1.75 because it is larger than 1. So now we want to look above those. Those guys are both open circles, so that means they are both going to have open circles above them. But let's pay attention to the direction that they go. If I start with this one over here on the left side, that tells me that I'm going to have to go to the right. So 1.75 is going to go to the right. So if I look at 1.75, I'm going to draw an arrow that is going to the right. Now notice that was on the right side of my number line, but was my left question. It's okay, no big deal. I just want you to understand that. When you look at the x is less than 1, that's telling me that I'm going to have to go to the left. So to go to the left, I'm going to go here at 1, and I'm just going to go to the left. Now, just like I said at the beginning, I said, hey, ORs are most of the time not going to be connected whatsoever. That means they're going opposite directions. Well, that's good. It's good to remember that too, because that means you may do something wrong when you are numbering these things. You should remember that, well, most of the time they're not going to be connected. So those are compound inequalities. We have the and we have the OR compound inequality, both of which I just solved for you.